Hi guys, this is me Kong again from Posh Coaching Classes. Thanks for joining me. Today we are going to discuss the rest of the questions of the exercise which we started in our previous video. That was exercise 8.1, class 10th trigonometry. So in our previous class we finished first 5 questions. So today we will finish off the rest of the 5 questions, and we will just be sure enough that what are the formulas we use in these type of questions, and let's get started. So today's question is question number 6 for us. And mind you, this is one of the important questions of this particular exercise, so you need to be very much vigilant about the question. So let me see what the question is. It says, if angle A and angle B are acute angles such that cos A is equal to cos B, show that angle A is equal to angle B. First of all, we should know what is an acute angle. You must be knowing it very well. The angles which are lesser than 90 degree, and between 0 to 90 they are acute angles. So let's make a small diagram first, just a figure. So let's see what the question says. Here is a triangle. I have a perpendicular here. So the question says angle A and angle B are acute angles. So these are acute angles. Let it be A, then B. Afterwards it says such that cos A is equal to cos B. So what is given? Angle A and angle B are acute angles. Also, cos A is equal to cos B. This point is very much important. We will see that later. And then what does it say? It say show that angle A is equal to angle B. So what do we have to prove? We have to prove angle A is equal to angle B. So what else? That's it. We have that much. Okay. So this is A, this is B, let it be C, let this be M. These are right angle triangles. So because of the trigonometry, let's see what do we do here. Now I have 2 triangles in one triangle here. If I see I have a triangle AMC, that is right angled at M. This is the triangle I'm talking about. And then I have another triangle, it is BMC. So we have 2 triangles. So let us see what can I say here. I can say in triangle AMC and triangle BMC, I have, let me put this as 1 and this 2. I have angle 1 is equal to angle 2. Why? Because each 90 degree. Clear? Right. Now what else it says? It says cos A is equal to cos B. This is given. Now if we remember the previous thing, P, B, P, H, H, B, sine, cos, tan, cosec, sec and cot. So what are we talking about? We are talking about cos A and cos B. So cos is base upon hypotenuse. This is the angle we are talking about. So cos A will be base, that is AM, upon hypotenuse is AC. Now cos B, so we are talking about this angle. So cos B, base is BM, then we have hypotenuse as BC. Clear? So this is one of the conditions that has been given by the question. I can say one more thing. Now here if I see AM upon AC is equal to BM upon BC, so I'll write here AM upon AC is equal to BM upon BC. Then we have another side, that is CM upon CM, because this side is similar to, it is the side which is actually used by this triangle and this triangle as well, so I can use it as this. Now I can say I have this thing and then I have this thing as well. So using similarity, I can say therefore triangle AMC is similar to triangle BMC by SSS, which means angle A is equal to angle B. Why? Because when the triangles are similar, we can say that the angles are also equal because we have the similar triangles here. Clear? So this is our question number 1. Let's move to question number 2. So let's move to question number 7. What does question number 7 say? So our question 7 says, if cot theta is equal to 7 upon 8. So we have cot theta equals to 7 upon 8. So let's make a triangle here. Obviously it has to be a right angle triangle. So we have theta. Let us put theta here. So we know P, B, P, H, H, B, sine, cos, tan, cosec, secant, cot. So we are talking about cot, that is base upon perpendicular. So this is base upon perpendicular. So base is 7 and perpendicular is 8. So what is the first thing to do? Obviously we have to find the third side. So what we will say? We'll say in the right angled triangle, using Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. Now hypotenuse is the one that we need to find, so let this be as it is. Then we have base, that is 7, so square, and then we have perpendicular, that is 8 square. Hypotenuse square, 7 multiplied by 7, 49, 8 multiplied by 8, 64. Hypotenuse square, 9, 13, 6, 10, this is 113, and then our hypotenuse square goes that side, so under root 113. So this is the hypotenuse which we were trying to find. Now 113 we cannot broke it, so it will be the same. So this is our hypotenuse. Now what does it say? Now we have all the sides. So now the question is asking, let me just take this off. Now what the question says, let me write that first and then we will try to solve it. So the first, we have two parts here. So the first part says 1 plus sine theta in the brackets multiplied by 1 minus cos sine theta whole divided by 1 plus cos theta, then 1 minus cos theta. Okay, so it's pretty much clear that first thing what we need to do is we need to find the values of sine theta and cos theta. Once we have the values, we can put those values here. So let's try and search the values. So we have sine theta. Let's find. So sine theta is perpendicular upon hypotenuse. This is theta, this is perpendicular, and this is hypotenuse. So that is 8 upon under root 113. How about cos theta? Let's see. Cos theta is base upon hypotenuse. Base upon hypotenuse. So base is 7 upon hypotenuse is under root 113. Clear? Now let's put these values here. Before that, I can do one thing. We know it. Okay, we'll write here. We know that a plus b multiplied by a minus b. What does that mean? That is a square minus b square. So if we see, we have a plus b multiplied by a minus b, and here as well in the denominator a plus b multiplied by a minus b. So I can write this as a square, that is 1 square, it will be the same, and minus sine square theta, because b square. Here also it will be the same, cos square theta. Right? Now 1 minus sine theta. We have the value of sine theta, that is 8 upon under root 113, but there is a square. Whole divided by 1 minus, we have cos theta. So cos theta is under root 7 upon under root 113. So we have a square here as well. Now it is 1 minus 8 multiplied by 8 is 64. Then under root 113, and there is a square there, so square and under root gone, so we have 113. Similarly here, 1 minus 7 multiplied by 7 is 49. Square and under root gone, so we have 113. Clear? Now let me go here and let's see, we have to take the LCM. So the LCM will be 113. 113 multiplied by this one is 113 minus 64 whole divided by, again the LCM will be 113. 113 multiplied by 1 is 113 minus 49. So now if I take 113 and 64, so we have 9, 4, so we have 49. So it is 49 upon 113 divided by 113 minus 49 is 64 divided by 113. Let's do the reciprocal here. 49 upon 113 multiplied by, this goes upside down, so this is 113 upon 64. 113 and 113 gone, so what do we have? We have 49 upon 64. Answer. Got it? So this is the answer of the first part. If you want to make a note of it, please do pause the video and don't get confused. We have a step here, and after this we are moving this side. So LCM, you must be knowing 113 multiplied by this, and once that is done, when we have the LCM and denominator same, we write exactly the same with what is in the numerator. So that's what I have done here. Same here as well. So this is question number 7, first part. We have to do the second part as well. So shall we? Okay, so the first part, it was quite a big one. Now the second part, it is not that big, so don't get bored. Trigonometry is one of the chapters, as I said earlier as well, it gives you a lot of marks, so please do concentrate on trigonometry. So what is the next one? It says cot square theta. Very simple. Cot, this is cot, that is base upon perpendicular, so base upon perpendicular, so we have 7 upon 8 square. What do we have? 7 multiplied by 7, 49. 8 multiplied by 8, 64. That's it. So this is our question number 7. As simple as that. Let's move to question number 8. Alright guys, so question number 8 here, let me just take this off first. Question number 8 here says, if 3 cot A is equal to 4. Question number 8. 3 cot A is equal to 4. So what I can do here, I can write cot A is equal to 4 upon 3. This 3 goes there. Now let's make a small figure here. P, B, P, H, H, P. And now I have A here, so it says cot A is equal to 4 upon 3. So cot is base upon perpendicular, so we have base and then we have perpendicular. Now what are we searching? What are we finding here? We are trying to find the hypotenuse. So let's find the hypotenuse using Pythagoras theorem. In triangle, let's give a name here, ABC, right angled at B, using Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. So hypotenuse, we don't know, let it be the way it is. Base is 4, then we have perpendicular 3, hypotenuse square, 4 square 16, then we have 9, hypotenuse square, this is 25, then we have hypotenuse under root, I can write 5 square, and now hypotenuse is equal to 5. So we got the third one. Now we can see what the question is asking. So now this is done. So let me just take this off and now see what the question is actually asking us to do. Now it says check whether 1 minus tan square A, so that is 1 minus tan square A whole divided by 1 plus tan square A is equal to cos square A minus sine square A. Got it? So now here, what are we trying to search? We are trying to search tan and then sine and cos as well. Once we have the values, we can put those values here. So let's write sine A, then we have cos A, and then tan A as well. So sine is perpendicular upon hypotenuse, cos is base upon hypotenuse, and tan is perpendicular upon base. Now sine perpendicular upon hypotenuse, so that is 3 upon 5. Cos base upon hypotenuse, that is 4 upon 5. Then we have tan perpendicular upon base, that is 3 upon 4. Okay, now I have the values here. Let us put these values. First, let's take RHS. Taking RHS. So what do I have? I have 1 minus tan square A upon 1 plus tan square A. So 1 minus tan. We have 3 upon 4, but there is a square. Then I have 1 plus tan, 3 upon 4, again a square here. So what does this become? It becomes 1 minus 9 upon 16 whole divided by 1 plus 9 upon 16. Now let's take the LCM. This is 16. 16 minus 9, just the way we did it in the previous question. Here also the LCM will be 16, so 16 plus 9. Now let me move to that side. So 16 minus 9, 10, 11, 12, 13, 14, 15, 16. That is 7 upon 16. Then 16 plus 9, that is 25 upon 16. So 7 upon 16 multiplied by upside down, that is 16 upon 25. 16, 16 gone. So RHS is 7 upon 25. So this is our RHS. Let me go ahead and take this off and take the values of the LHS as well. So we have the answer of left hand side, that is 7 upon 25. Let me put the values here. So now cos, taking RHS, cos we have 4 upon 5, so 4 upon 5 square. Then sine we have 3 upon 5 square. 4 multiplied by 4 is 16 upon 25. 9 upon 25. Let's take the LCM. So it's 16 minus 9, that is 7 upon 25. So LHS and RHS both are equal. So I can say yes, they are equal. Got it? Very simple question. Question number 8. Let us move to question number 9. We have question number 9, and then there is one more question, that is question number 10. And once that is done, we are done with our first exercise. So what does question number 9 say? Give me a second, let me see. Okay. So question number 9 here on the book, it says in a triangle ABC. So again we have a triangle. Okay. Does it say where's the right angle? Right angle at B. So we have B here. Let the A be here and C here. If tan A is equal to 1 upon root 3. Okay. Let me do a small change. Let me put an A here and C here. Why? Because if A was here, then I would have taken this angle, and then we have to use this as perpendicular, this as base. Let's take this A, and then this will be the perpendicular and this will be the base. Nothing changed as of now. So we have tan A equals to 1 upon under root 3. So what do we have tan here? Perpendicular upon base. So this is perpendicular and this is base. So perpendicular is 1 and base is under root 3. So let us find the value of hypotenuse. So in right angled triangle ABC, using Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. Hypotenuse, then we have base, that is under root 3, and perpendicular 1. So square and root gone. We have hypotenuse square is equal to 3 plus 1 multiply 1, no changes, so it is 1. So hypotenuse square is equal to 4. Hypotenuse is under root 2 square, that means hypotenuse is equal to 2. So what do I have? Hypotenuse, that is 2. Now let's see what question says. It says find the value of, alright, so first part, we have two parts here. So the first part, it says okay, sine A cos C plus cos A sine C. So the first part is sine A cos C, and then plus cos A sine C. Okay, so what do I have to have? I need to have value of sine A, then I need to have the value of cos A, and even I need to have the values of sine C and cos C. So let us try and find that. Sine means perpendicular upon hypotenuse. So perpendicular is when we are talking about this angle. Mind you, we have another set as well. So there we have to talk about this angle. So this is this angle. So perpendicular upon hypotenuse. So 1 upon 2. Cos A is base upon hypotenuse. So we have base as under root 3 when we are talking about this angle. And then we have hypotenuse, that will be the same, no changes. Now we are talking about this angle because it's C, so sine C, perpendicular, so this is perpendicular, so under root 3 upon hypotenuse will be 2, then cos C base is 1 upon hypotenuse is under root 3. So let's put the values there. So we have sine A, that is 1 upon 2, then we have cos C, that is cos C 1 upon under root 3, then plus cos A. Cos A is under root 3 upon 2, and then we have sine C, that is under root 3 upon 2. So here if I say it's sine A cos C, okay, and here, okay, so it's 1 multiply 1, that is 2 under root 3 plus this is 3 upon 4. Sine A cos C. So sine A cos C. Cos C is okay. I made a mistake here. That's what I was searching because we have hypotenuse. So I'm talking about cos. Cos is base upon hypotenuse. So base is 1 and hypotenuse is 2. Okay. So don't make that mistake. So we have 1, that is 2 multiplied by 2 is 4. Now let's take an LCM. So it is 1 plus 3, that is 4 upon 4. So we are done. So the answer is 1. That is the first part. Now we have another part. It says we need to have the same values as of now. That is cos A, cos C. We have cos A, we have cos C, then sin A, sin C. Yes, we do have all the things there. I'm just rubbing this off. Now the next part says cos A cos C, cos A cos C minus sin A sin C, sin A sin C. So cos A is under root 3 upon 2, then we have cos C, that is 1 upon 2, minus sin A is 1 upon 2 and sin C is under root 3 upon 2. So this is under root 3 upon 4 minus under root 3 upon 4, both positive negative, so the answer will be 0. Clear guys? Very important question, so please make a note of this, and I'll move to the question number 10 now. Okay, so this is question number 9. Let me go to question number 10. All right. All right, guys. So question number 10, it says in a triangle PQR, so right angled at Q. So I have a triangle that is PQR and that is right angled at Q. Now what else it says? It says PR plus QR is equal to 25. So given we have a triangle PQR right angled at Q, and then we have PR plus QR equals to 25 centimeter and PQ equals to 5 centimeter. So do we have PQ? Yes, this is PQ. So this is 5 centimeter. Now what else? Determine the values of sine P, cos P. That's later. So let us first see what we have been given. There is a right angle triangle. Yes, we can use the trigonometric ratios here. We have one side. Perfect. Now, till now, whatever questions we did, all the questions had actually two sides and we had to find just the one. But in this particular question, we have just the one side and there is one thing given, that is PR plus QR. So if you see this side and this side, they both add together and make 25. So what do we have to do now? We have to find both the values, then only we can solve it. So let's see, if I say using PGT, obviously I'm supposed to use PGT because there is a right angle triangle. So let me see, it's what we can do. We can say hypotenuse square is equal to base square plus perpendicular square. Now what do I have? I have hypotenuse is PR, so I'll write it as PR square. Then I have base QR square and perpendicular is PQ square. Okay, now if I take this equation, let me see, if I say PR is equal to 25 minus QR, what I did, I just took this QR, this is positive QR, I took it this side, it became negative QR. Now PR square, there's a value for PR, so I can put 25 minus QR square. QR is just the way it is, and PQ we have 5 centimeters, so I can put 5 here. Now what is this? This is A minus B whole square. So let me elaborate it. It's A square plus B square minus 2AB. Okay, now this is QR square plus 25. Now this is 25 multiplied by 25, that is 625 plus QR square minus 50 QR is equal to QR square plus 25. If I see I have a QR square here and here as well, let me take that off. Now what do I have? I have minus 50 QR equals to 25, this one, and this positive 625 goes that side, becomes negative 625. Now minus 50 QR, 625 minus 25 is minus 600. I'll take this and this off. QR is equal to 600 upon 50. So this 0 and 0 goes, 5 12s. So I have QR equals to 12. Now we are on the right path. So we have one value here. So this is 12. Do I have to have any more things? Yes. I have one more side, that is PR. So I have PR here. So let me do it here. So PR is equal to 25 minus QR. Now I have the value of QR, that is 12. So PR is equal to 13 centimeters. So this is 13, right? So now we have all the values of the sides of this particular triangle. Now we can see what the question is asking. So we have been asked to find sine P, then we are searching for cos P, and at last we have tan P. So sine, that is obviously perpendicular upon hypotenuse, cos base upon hypotenuse, and tan perpendicular upon base. Now the real thing to know is which angle are we talking about. We are not talking about this angle, we are talking about this angle. So this is P. So now perpendicular, for this angle the perpendicular is 12 and hypotenuse is 13. For this angle base is 5 and hypotenuse is 13, and for this angle perpendicular obviously is 12 and base is 5. So these are the answers. Sine P is equal to 12 upon 13, cos P is equal to 5 upon 13, and the tan P is equal to 12 upon 5. So this was question number 10, and very important question from my point of view. So please do practice these questions. This finishes our exercise number first. We are done with first exercise, quite an interesting one. So we will meet in the next video. In our we will be doing the next exercise, which is 8.2. Very interesting exercise. We will learn few more formulas there. Till then, keep watching, keep learning, and keep subscribing to Posh Coaching Classes. Ask your friends who are in 10th standard to subscribe to our channel. So this is me signing off for today. Thank you so much for watching the video. You have a wonderful time. God bless. Take care.
We'll be right back.